3B. So we discuss about what is network and devices like a router, modem kind of stuff, switches and hubs. And also we discuss the difference between switch and hub. What is a router? What is trace RT? Okay. We'll see once again. So what is an IP address and MAC address kind of stuff? Okay. IP address is a logical address. What is an IP address? Uniquely identify a device in the network. Okay. So every device need an IP address to communicate in the network. Every device need an IP address to communicate in the network. Okay. IP addresses is changeable and it is assigned by user like a manually we can able to assign, that is called static IP, and dynamically we can able to assign through DHCP server. So IPv4 having 32-bit and 64-bit. Okay. So IPv4 32-bit, IPv6 128-bit. So there is no 64 here. So please remember, because when you hear 32, next one is 64. So be confident. So IPv4 is 32-bit, IPv6 is 128-bit. There is no IPv5, no IPv7. In sometimes in interview, some people will wantedly ask to confuse the people, okay? So or to check your confidence. So they'll, what about IPv5? What about IPv7? So have you not checked recently? So this is the new update is came. What is IPv8? Or what is 64-bit IP? Okay, but 256. Okay, what is the 16-bit IP? So people will confuse, guys. As standard from the IANA ICANN, there is only two IP addresses. One is IPv4, IP version 4, IP version 6. Okay, so IPv4 is 32-bit, IPv6 is 128-bit. So 4.3, almost all 4.3 billion IP addresses we are getting in the IPv4. In IPv6, so we are getting almost 3.4 billions means decillion. Exactly, say the word is decillion. So 3.4 into 10 to the power of 38. Okay, so IPv4 is in a decimal format, IPv6 is hexadecimal format. So IPv4 has a limitation. So 4.3 billion, almost
Hello,
like
sir.
a, yeah, tell me.
Sir, sorry to interrupt, sir. I just joined because of no network issue in my locality. So please
Okay,
consider
okay,
my
okay.
advice.
Yeah,
Yeah,
okay. No problem. Astan.
Sheikh Mastan Sharif, sir.
Yeah, I got it. Here it is.
Thank you, sir.
Ah, okay. So this is how IPv4 is look like. So you can see it is total. If you write this one in the binary, it is totally 32-bit. And this entire 32-bit is divided into four parts. See, this is one part, second part, and third part, and fourth part. Okay, so it is divided into four parts and separated by dot. So when you read the IP address, you have to read like this only: 192 dot 168 dot 1 dot 34. IPv4 is divided into four parts. Okay, so if you divide into four parts, it is 32 by 4. It's a 8-bit called a octet. Means each part we call it as a octet. So each part is 8-bit. So totally 4 8s 32 and divided by dot. So 2 to the power of 8 is 256, means if you write a number wise like from 0 to 255. Min is each octet is range from 0 to 255 only, not more than 255. Okay, there is no minus numbers anyway. Okay, so each octet is maximum of 0 to 255. Okay, some people represent this first octet, second octet, third octet, fourth octet with W, X, Y, Z. Okay, this is the first octet. And and if you write an IP address, the total range from 0.0.0 to 255.255.255. Okay, this entire IP address range, if you start writing from 0.0.0 to one by one, you write last one, it is become 255, 255, that is the highest. And this entire range is divided into 5 classes. The class is based on the first octet only. We can understand which IP address is which class is based on the first octet. So these classes, actually there is a binary numbers are there. So I removed that one to reduce the reading time. Okay. So like if when you read it, it should be make it much easier. Okay. So IP address range is divided. The entire IP address is divided into 5 classes. And based on the first octet, it will be recognized. Class A 0 to 127, Class B 128 to 191, Class C 192 to 223, Class D 224 to 239, Class E 240 to 255. So these are the 5 classes. In this one, the Class D and Class E, we don't assign Class D IP addresses, Class E IP addresses, we don't assign to any of our networking devices. Okay, to the systems, like to the PCs, servers, laptops, mobile phones, or to the routers also, gateways, firewalls. We don't assign these IP address to them. Okay, which one is Class D, which is multicast. Class C is a research and development, means there is a reserved IP addresses for some specific usage or further usage purpose. Okay, so what is this multicast address? It is used by certain protocols in their type of communication. For example, routing protocols, RIP, AGRP, OSPF, or deployment protocols using WDS kind of stuff. So there it will use the multicast itself. Okay. And Class A, Class B, Class C are unicast IP addresses. Out of this, so there is a mainly 2 IP addresses we cannot assign to the devices. Of course, there is one more IP already. It is I didn't told, but I will tell definitely somewhere I've written or somewhere I missed it. Okay, I think I missed it. Okay, here I will add it that one later. We cannot assign or configure IP addresses to a device. What kind of IP addresses? 0.0.0.0 is a reserved IP address. So if it is a question, guys, so why not you use 0.0.0.0? Is that is a reserved IP address that is used by certain protocols like DHCP protocol in the configuration purpose, like DHCP protocol means for a configuration purpose, default routing places, yellow defining, yellow all, deny all kind of places. Also, people use this kind of specific thing. Okay. And anyway, this entire zero series, we don't use it. 127.0.0.1 is also a reserved IP address, loopback or local host, self-testing, self-accessing purpose. Means in my PC, if I have a web services or maybe if I have a database services, so I want to access in my PC, from my PC, means both server and client are in a same system. Both service, both are in the same system. Second one is self-testing purpose. We use this IP address. It is reserved for a loopback and local host IP address. Anyway, 127 series entirely we don't use it.
Sir, sorry to interrupt, sir. Navistri present, sir.
And now we actually came. Very good.
Yeah.
that here it is. Yeah, we know already. So how to identify which class of IP address it is based on their first octet. So what are the other octets showing either it is small number or big number? Don't worry. Always see the first octet and check with this table which class of it is. Okay, so that is the point. So here it is. Next important point is, so our IP address, this is because already I told this one last Saturday. Okay, just I'm revising. IP address is divided into network and host portions. Whatsoever it is an IP address, that too what IP address we are using, class A, class B, class C only. For these things only we are using, so we have to talk about those things. You take an IP address, this IP address is two parts. One is a network part, another one is a host part. Okay, this is for our understanding purpose. Just have written some roll numbers here. This is some 22. This is starting is 23. So this 23 represent the year. I think while explaining that time, so I have written this thing. Okay, so it's not a 23 batch. See, this is 23. So 2023. So I put a year. So I can recognize these are all people. They're based on their roll number. There is belongs to 2023. But this roll number is not 2023. Okay. So and here it is. You can see. Yeah. So January batch, February batch, like this, like a Hyderabad batch, Noida batch kind of stuff. You can see the difference here. 19th batch, 19th, 19 batch it is. This is 18 batch. And this is again 19 batch. This is their roll numbers like that. Because it's like a, divisional parts. Okay. There is some other examples also there to explain. This one last class we explained the floor and door number type. It's become more specifications in a network and kind of stuff. But again, it's become a different canvas. Okay, I'm not going to the in-depth explanation. Just remembering points are important because we don't have much time on it. Okay, class A is a 0 to 127. Okay, so it is also in certain textbook 1 to 126. Guys, someone asked, how can you tell it is 0 to 127 and it is showing here 1 to 126? You can say, sir, it is right because original range is 0 to 127. The 0.0.00 and the entire 0 is reserved for a certain protocol use. So we are not able to assign the 0.0.0 and as well as entire 0 series. So that's why it starts from 1. Next one is 126. Yeah, why not 127? 127.0.0.1 is a loopback or localhost IP address, which is reserved for that purpose, and entire 127 series also reserved for this loopback or localhost purposes in different places. Okay, so we are not using 0 series and 127 series. That's why certain places it is written 1 to 126. The original range is 0 to 127. So why I'm repeating, guys, compulsory remember these ranges and other few kind of stuff. Okay. And by default, the IP address, if you take an IP address, the first part of IP address, first octet is network part and remaining become host part in a class A. And class B, first two are network part, remaining is host parts. In a class C, first three are network part, last one is host part. Okay, so here is a certain rules I have written. That is, the IP address is divided into network portion and host portion. Network portion represent which network it is. Host portion is the just a host number. Like I have a 10 servers. So I put a like this host number like a 1, 2, 3, 4, 5 for server 1, server 2, server 3, server 4. Like that I put a some naming. What is the 1, 2, 3 represent? That's numbering for each one. Server means it is a server, it is a representation. Like that, simple to understand, guys. The host portion represent a simple host number. Network portion represents, okay, which network it is belongs to. Logically, which network it is belongs to. So you have a 10 computers. You want to make all 10 computers to communicate each other in a single LAN network or single segment network. Okay, their network portion must be same. And host portion is always different. Maybe in a one portion or maybe in a multiple portions, there must be a small difference is there. Okay. So anyway, one difference is enough because it is original ID. So you can see this is your roll number, for example. This is your roll number. Roll numbers are not same for a same batch, right? It can be same in some other place, some other class roll number. For example, your batch 3. Your roll number is 0, 1, 2, 3, batch 3, roll number 1, 2, 3. So I will try to put it that way. So better I will write. Always understand, guys. Core concept, concept wise, I try to your batch 3. So I given a roll numbers batch 3, 0, 1, 9. Sorry, it's not. So each person will get a some unique number, but common number is 0, 3. What is the 0, 3 represent? Batch number. 1, 2, 3, 4 represent. For example, batch 2 is also there. For example, batch 2. Okay, this is batch 2. Okay, so same numbers. If you see same numbers, but not same batch, right? They're having the same numbers. They can have same numbers, but not a same batch. It means both are different batches. Same way, network and host. So same network means the network portion must be same. Okay, and host is different, compulsory different. Otherwise, what will happen? Conflict will occur. For example, I assign same number to two people. This is both are having same number. In our names, generally we didn't have any repeated name. As I remember, no one is having a repeated name. Okay, so no problem. But if in case repeated names are there, then there is a small problem. But if you have a what you say, the serial numbers, if I assigned repeatedly, any repeated is there like this, it is called a conflict. If two numbers having same roll number, conflict. Two systems having same IP address is conflict. Means both network and host portion is also same, means it is a conflict. Okay, and network portion must be same in case of things. Okay, you want to communicate. So here it is. If devices are want to communicate in the network, means in the simple single LAN network, if they want to require to communicate, their network portion must be same. Host portion can be different. I have written can be different because I cannot write entire line, because if you see this is the host portion is one host portion. It is different definitely. Okay, should be different. Here it is two host portions. Any one of the host portion is different. Now, okay, any one of the host portion is different. Still, it is different host. But network portion must be same in the same network. Devices are in the same network can communicate each other, means their network portion is same. Devices are in same network means their network ID is same. So find out what is the network ID. So this is same or not. Okay. Check the network portion. First, check it which class of IP address it is. When you got a computer's IP addresses, you got a IP addresses, 10 IP addresses. So is this 10 computers are in the same network or not? If same network, they will communicate each other. See, not the same network, they won't communicate it. First of all, check their network ID, means check their class. Based on the class, by default, what is their network portion and host portion. This is the network portion is 110, one network portion is 110, network portion is 111. So this PC is with three PCs, PC1, PC2 can communicate, but PC3 cannot communicate with the PC1 and PC2. The same goes for everything. Even though one of the network portion is different from our regular network portion, is also won't communicate each other. And already I told yesterday, by mistake you entered wrongly and you are not able to communicate. So compulsory verify the IP address. Two systems in the same physical network are not able to communicate. Check their IP address. Check the connectivity. Check the IP address. Make sure that both the IP addresses in the same network are not. Both IP addresses are in same network or not. PC1 and PC2 can communicate, PC3, PC4, PC5 cannot. Why? There is a network in the somewhere in the network portion, it is different. And very important, guys, host portion should not be same for a two or more devices. Should not be same for a two or more devices. So here it is also, I'll write that point is host portion should not be same in same network. Okay, should not be same. Means as it is, should not be same. Not one difference is allowed, and more difference is also allowed. But same to same. The same network. Okay, should not be same to same. Otherwise, I'll write the entire host portion should not be same. The same network. So this is the point. This will in the same network. Host portion, entire host portion should not be same. At least one, at least already I have written at least. Okay, I will extend this one. At least, one of the host portion must be different. At least means either all host portions or at least one portion should be different. Okay, guys. So this is one of the important point. Okay, guys, up to here understand. So what is an IP address and what are the classes and their ranges? What IP address we cannot assign to the devices? What range of IP addresses we use? Okay, what range of IP addresses use it? Okay, and how to identify IP address? Which class of it is? What is network and host portions? What is meant by same network? Do you understand up to here?
Yes, sir.
Durga Prasad. Prakash. Okay. So compulsory these things remember guys anyway. So not only just for getting this job guys, in future you want to learn cloud computing, you want to learn some networking side like a CCNA, CCNP kind of stuff. The core concepts always important. Even for a cloud, some people, not some people, most of the people are believing that it is cloud is completely different technologies. No, cloud is an infrastructure part or a platform as a service part. These concepts are always same. Without knowing a network, you cannot do anything in a cloud. Without knowing a concepts like a load balancer, server concept, Linux-based concepts, you cannot learn the cloud. Even you learn the cloud, that is useless. Just you know the service names only. How to create that shit really cannot work. Really, it means again you have to read. So this is very helpful. Like once you are clearly understand what is private IP, what is public IP, what is this subnet mask, what is this ACL kind of like firewall related router concepts, if you know. So that will help you when you are going to learn those technologies. And that's what I'm trying to say. Okay, and not like that you learn, don't know, don't learn. Like I'm not talking. So you learn these things, which is helpful. These concepts always helpful to learn further. Either you are going through network related, server related, cloud related, always helpful. Same concept. It's a core concept. It is. How system can divide network and host portion. How to find a network ID. So you have a system and you assign an IP address to it. Okay, so you assign an IP address to it, then how you will understand what network it is, but how system will understand what is the network ID and what is the network portion and host portion. So it is based on the subnet mask. So when you assign an IP address, for example, you assign a IP address based system. So based on their classes, based on their class, how it will know based on the first octet. So it's a 178 class B, 178 class B. Okay, just check it. 178 is in between these two numbers. It means it's a class B. We know class B. What is the network portion? 178.9 is the network portion and 80.99 is a host portion. Okay. So if you have a two system, three system, 10 systems, the network portion must be same. The remaining thing can be changed. Okay. This portion can be anything. This portion can be anything, but these two portion must be same. But how system will understand? System by understanding its subnet mask. Okay, so when you assign an IP address, you must assign a subnet mask. The default subnet mask for class B IP address is 255.255.0.0. Okay, so it is a default subnet mask. I said default means by default means whenever you are assigning an IP address, automatically it will take the default part of IP address. Where is that? Yeah, here it is. If you take a class A, 255.0.0.0 is your default subnet mask. So where is the network portion by default? So that place you can see 255. So here it is two are network portions. You can see 255, 255. And host is 00. Again, class C, the network is three networks, 255, 255, 255. Only single host, only single zero. Actually, the 255 you write in a binary, it is 8 ones, means all are ones only. So it's 1 represent network, 0 represent host. 0 means all are zeros, 255 means all are ones, 8 ones. Okay. So if you write in the binary, this is 8 ones, 8 ones, 8 zeros, 8 zeros. Okay. Point is, guys, so of course we have a IP address and we have a subnet mask. From this one, our system will extract the network ID. How it will extract the network ID? Using AND operation. Logical AND or operations, AND operation, or operation, not operation, NAND operation, NOR operation. Okay. Logical operations, logical gates. Do you have still remember?
Yes, sir.
Very good. Very good. Okay. So this is AND gate operation. It is AND gate operation. You take two inputs, A and B, the Y is an output, and the expression for this type of thing is A dot B. Okay. If take A is a 0 and B is also 0, the output is 0. A is 0, B is 0, output is 0. A is 1, B is 0, and output is 0. If you take both inputs are ones, the output is 1. It means both are high, output is high. Any one of input is low, output is low. Okay. If any of the input is low, output is low. Or you can say if both inputs are true, output is true. If any one of the input is false, output is false. It's a truth table because this is commonly we know in any branch you are belongs to this logical gates are most common understanding because it's not a engineering subject. It is from your 10th class subject on truth tables. Okay. In subnet mask, ones represent network bit, 0 represents host bits. The 255, oh, I've written here, means 8 ones and 0 means zeros. And I have written here, you can see this is the class C IP address. Class C means first three portions are network portions. You can see the first three portions are network portion. Remaining is host portion. The starting is with a 0. So this is called a network ID, which we cannot assign to any device. This total number represents network ID. This is the network portion, and this is totally network ID, which we cannot assign to any devices. The next one is the actual IP address, which we can able to assign to any devices. And if you keep go on 1, 2, 3, 4, 5, the last one you reach, that is called a 255.2. Sorry. Last one you reach, the network portion is same from starting to here. You can observe first starting to here network portion is same. Only thing is it reaches 255. If you cross this one, the network portion is become another network. So it is 1, this is 2. So automatically network portion is changed. This last one called a broadcast ID. This one also we can't assign to any device. So we can assign from here to here. So 1 to 254. Because it's a class C, it's simple to write. Class B, it is very big to write. Okay. So class is simple to understand and write. So if you see this one in a class C, from 1 to 254 IP addresses we are getting from 1 to 254. You take a systems, for example, in your network, you have a computers, okay, and you are try to assign an IP address. The network portion is always same, right? So I started assign 1, 2, last one on 3, 4, 5, 6, 7, 8, 9, 10. Okay, so exactly 10 we have written. Okay, so from here you can see 1, 2, 3, 4, 5, like a one by one system, I'm giving an IP address. And it should not be repeated. The first portion, that network portion is always same, like a 192.168.1.1. So This is a network version. This is host. Only I have written host. This one is same for everyone. Network version is same for everyone. Guys, understand this example, this particular example. I have a 10 computers, SN and IP address with the same network version, but different host versions. Up to here, understand this one? I have a computers and I want to assign an IP address. So I started assigning IP address to each and every device. Start from 1, 2, 3, 4, 5 like that. Okay, for each device. And their network version is always same. So no one is talking.
Understood, sir.
Very good.
Yes.
Okay. So here it is. What I've done, I'm keep assigning IP address. So that is 10, this is 11, 12, 13, 14, 15, 16, 17, 18, 19. Again, we got 20. Very good. So what is the last one? So I have a lot of devices are there. Like I will keep assigning like a 1, 2, 3, 4, 5, 6. What is the last number I can able to assign in the series, in this series, in this one? This is the first one, second one, third one, fourth one. I keep going. What is the last number I can able to assign? Anyone? I showed an answer also. Last host. What is the number?
254.
Very good. 254. That is a last host. If I have a 300 computers, I cannot assign this last 254. Then it is become second another network. Okay. So maximum number of hosts we can assign up to 254 in a class C. In a class C. So we can able to assign maximum number of IP addresses 254. Okay. So that is the point. In a one single class C IP address, you take anything, any class C IP address. First three are network versions, so first three are stable. Only last portion is changes. And maximum number of systems in the single class C, in single network is 254. Very good, very good. Okay. If you take class B, you take a class B. Class B, two portions are network portion, remaining is host portion. So you have a computers like this in a class B, for example. Okay. I started assigning this series. This is the network portion, network ID. This is the first IP address. Okay, this is the first IP address. Okay, first valid host. For a host, I can able to assign. So again, I have taken these devices like multiple devices. Okay, I am taking. So for example, I am assigning one by one very sequence. So important part is this is should not be changed. This is I am going one by one. So here it is. I put a 0.1, 0.2. Second part 0.3. The first two are always same. In a class B, always same. 0.4, 0.5. Okay, I keep going again. So once it is reached, once it is reached 0.255. Okay, so then again I will assign 1.0. 1.0, 1.1, 1.2. So I'll keep going. and I reach 1.255. Then it starts 2.0. It keep going. What is the last means outside means broadcast is 255.255. What is the last but one? 255.254. Class B is little confusion as compared to class A, class C. Okay. So here it is. This is the broadcast. And this is our last IP address. This is the first IP address. This is our last IP address. So you can assign 1 by 1, 0.1, 0.2, 0.3 like this. Here keep assigning. First two portions are not changing. Okay. So this is like a 0.0 is a network portion. Okay. But this is first device, second device like that. You know how many? So we'll keep trying this one 172.16.0.2. Keep going 172.16 1 dot sorry 0.255. It is not completed because so it has to go up to change of this network ID. If you are keep writing 1.0, still network ID is not changed. You can see network ID is not changed. Same it goes 116.1.1. So to keep going, it goes up to here. What is this? Not last ID, it is a broadcast ID. This is called a broadcast ID. This is last valid host ID or host IP address, you can say. So you can assign from here to here. It is not 254. It is now two portions. So it is different, right? So two host portions means 2 8s, 2 to the power of 16. It is 65,534. Why minus 2? Already I told. The very first one is network ID, which we are not assigned to anyone. The very last one is broadcast ID, which is we are not assigning to any device. So these are the valid host, 65,534. Okay, guys, understand class B?
Yes, sir.
We take a class A, very good. This is again just an example. It is network ID, and this is first valid. Okay. Again, we start assigning 0.0.0.2. So you keep assigning to the devices. So then you reach 0.0.255. Then you will go for a 0.0.1, sorry, 1.0. Again 10.0.0.1.1, and you keep going on. So you reach almost like a 10.255.255.254. 10.255.255.255 is not a last, it is broadcast. And what is this? This is the last one. It's look like a small, but if you want, I will make it much bigger. Okay, so you reach 255, 255. What will be there? So sorry, 1.255 you reach 10.0.2.0. So it goes on like a 10 dot 255, 255. So 10.1.0.0. Cycle repeats always. Okay. 10.1.0.1. Keep goes. Okay. So This is the last one. So after this one, it is 11.0.0.0. It is some other network. It is some other network. Okay. So here it is. The system, where are we? Yeah, that is a class A. So if you look at, here is a three host portions. One single network portion, then a single network portion become other network once it is reached the last. The very last one and very first one, we are not assigned to anyone. We are assigning from here to up to here we are can able to assign. That is three host portions, right? So 2 to the power of 24, it is become a 16 million 777,214 number of hosts we can able to assign. Okay. So depends upon which range you select, which depends upon your organization, how many systems you have. For example, I have only 50 computers, 100 computers, 200 computers. What is a suitable class? Like you are working in an organization and there is a 50 computers in your organization. Your boss asked what is the suitable class you suggest to assign an IP address to all the system. Which class you suggest? You have only 50 computers. Which class is best without wasting more IP address?
Class A.
Okay. Class A, anyone? I have only 50 computers. Okay. And I have to assign IP address to all the 50 IP address, all the 50 systems. So I need a 50. And if I assign if I take one class of IP address, and I should not waste IP address. I have to save IP address. So I should not waste. Which class?
C.
C. Okay. YC, YA, YB, why not A, why not B, why not C? Very good. 254 hosts per network. Okay, you take a class C to assign an IP address to these devices. Okay, so in a one single class C network, for example, you take 192.168.2.0 network. So this is not changing. This is the host portion. We'll get 1 to 254 number of hosts. I have only 50 computers. So I assign almost 204 IP addresses. I'm wasting. But if you take class B, take class B 172, 16, 0.0 is starting. Okay, this is host version, and I'm getting a 65,535 for host. I have 50 computers, almost like a 65,000 for 84 IP addresses are wasting. See which one is more waste? This is better utilization. This is more waste. If you take class A, it is 16 million IP addresses in single network. So you are wasting more IP address. So like that. So number of hosts in your network in a future, number of hosts can be increased in your network. Based on that, you can able to assign an IP address. So here it is. I have a 50. Number of hosts are 50 only. For example, my boss added another 50. Now it is become 100. Which is better? Again, class C, because you still have a 254. Out of 254, you are assigned 100, still we have 154. Now your total computers are 200, still class C only. Your total computers are 300, class C not support because class C is 254. So you have to move to class B. Okay. So class B give up to 65,000. So no problem. It is a 500, even a 1,000 or a 2,000, 3,000 up to 65,000 number of hosts. No problem. Okay. So depends upon current and future configurations, future number of hosts you require. So based on that, we choose either class C or class B or class A. Okay, guys, understand this one, how to choose? Anyone, please? Okay. Guys, subnetting. This is yesterday, last class, I didn't explain what is a subnetting. I explained up to here, but from here I didn't explain. Here it is a concept why classes, IP addresses are divided into classes. And one more concept is called subnetting and private and public IP addresses. And the technique to communicate from private to public. So these are the concepts are important in our regular day-to-day communication. So we'll see IP addresses are from 0.0.0.02 to 55, 255, 255, 255. It is divided into 5 classes. And majorly we use the first 3 classes only. And it is divided based on the host and network portion. Different classes, different host and network portions are there. Okay, with a different subnet mask. Why all these things are there, guys? To utilize best utilization of IP addresses, both locally and globally. Means public IP address wise means publicly you are communicating outside. There's a lot of servers are there, so they need an IP address. There are a lot of different organizations also required IP addresses. Okay. Again, in a public, we have a lot of IP addresses. Okay, so we need an IP addresses which can able to facilitate these number of devices to communicate. In our private network means in a home or office networks, also we need an IP address to communicate. So for all these things, for a number of devices wise communication, okay. Um, Private communication within the private network, public communication outside of the network communication. So there with all these calculations, they divided the IP address into multiple classes. Okay. And they started utilizing this subnet mask concept to divide our network into host portion and network portion. What is the use of subnet mask? It is used to divide our IP address into network and host portions. System used to calculate our network portion using a AND gate operation. Okay, I didn't show how to calculate, but I showed this one. Okay, I will try that. I will show you that one here. Okay. Next, the IP addresses also there is a two types they given in the IPv for the private IP and public IP addresses. Okay, so what is these private IP addresses? Private IP addresses are used within the local network only, not for communicating to public network. You check my IP address. My IP address is private IP address to communicate within the local. Okay, so these are the different ways to best utilizing our IP addresses. Okay. Um, I will get back to this private IP because this is a line. Before going to this subnetting concept, I will show you one of thing is like how to calculate subnet mask. Sorry, where I have written So how to find a network ID? Okay. How to find network ID of a IP address. Okay. So check it here, guys. Just to take an example, I have a 183.415.33.44. This is my, what is this? This is my IP address. And every IP address having a subnet mask, right? 255.255. I am writing default one. I'm writing the default one. So what we need, network ID. What is a need? Network ID. So first of all, to do this one the traditional way, to do this one in the traditional way, so we need to convert this one into binary format. 183 in the binary. So if you use a calculators, also you can convert it, or you can use Google based, means browser based calculators also available, applications also available. So if you want, you can try this one, programmer. Okay. So I use 183. Okay. So this is the binary number. So compulsory convert into 8-bit matter. It is already 8-bit wise. So 1011 011. So you can try 1011 011. Or you can directly write, if you know the calculation how to convert binary to decimal kind of stuff using different techniques, you can do it also. You can write it like this is 15. 33 again, 0 0 1 0. So this is called 32. So I need 33. This is 33. Okay. Just you know the technique, so you can able to write again 0 0. This is 32. If you remove 32, then it is become full. So again it is 16 8 0 1 0. This is 44. If you have a doubt in my, I will try to show you this. So put it. Yeah, so it is 42. I got it. So I got it 42 with this number. Somewhere I have written wrongly. Yeah, I have done wrong because this is 1, this is 0. Okay, 32 plus 16 plus 8. So actually, I put a 16 plus, sorry, 2, 4, 16. No, still wrong. Yes, it's 32, 12, 8 plus 4. Correct, correct. This is correct. Okay. So in my speed correction, I have done a mistake in my speed. Yeah, it is 44. Okay, it is 44. This is correct. This is exactly correct. Because I written 33, that is no mistake in it. Okay, it is 33. Even for a big one, we can able to calculate. Okay, simple calculation. So these are 255s. It is simple. Already I told. This is 255 means all eight are ones only. Ones. 0 means automatically all 8 bits are zeros. All are zeros only. Okay. So now it is need a network ID. Okay. So here it is end operation. In the end operation, guys, you do these two things like this, like this, like this. One is one. If 10 or 01 or 00, you have to put a 0. So here also check it 11. So then it will get a 1 only. And next one is 01. You can see this is 0, this is 1. So then you put a 0. Then 11. Put a 11. 01. Okay. Then 1. Next. See, this is first one. See, it is 0 1 0. Here also 0 1 0. Remaining are 1 1 only. Again, this is 0, this is 1. So then if it is, we will get a zeros only. These are a 0 1 0 1 0 1 0 1. These are all 1 1s only. Okay. So these are all 1 1 1 1. We will get it. 0 1 again 0 0 1 1 0 0 0 0 0 0 0 0 0 0 1 0 0 0 0 0 1 0 0 0 1 0 1 0 0 0 0 0. So this is our network ID. If you write in a decimal format, so you have to convert this thing into again decimal format. Zero zeros are okay, but so what is this number? This is 128 plus 32. It is 160 plus 16, 170. 176 plus 7. 176 plus 7. How much it is? 184. No, no, no. 6 plus 7, 6, 4, 3, 183. So 183. Yeah, 183 only. Yeah, 183. That is 15. We know that one. So remaining is 0. It's correct or no? No mistakes. So if you want, I will copy, put it, paste, binary, paste. So 183 only. So no mistake in it. Because I calculated this. Okay. So this is our network ID. Okay. So you have IP address, you have a subnet mask, you have a now network ID. How we calculate network ID? We convert our IP address, subnet mask into binary format, and we got a network ID. Guys, understand how to calculate network ID, how system will calculate our network ID. If same network ID for two or more means same network ID between the systems, they will communicate each other. Understand this part? Or can I do it again?
So 1 second, sir.
Okay, so I have taken an IP address. I have some IP address. Why not? So I have an IP address here. Of course, it is different IP here. Okay. So I have taken some IP address. Here is 192.168.23, um, uh, 24. This is my IP address on system. So it is a class B, right? It is a class C. Class C means first three portions are network portions, and these are all, sorry, okay, remember last one is host portion. The default subnet mask I have written that is 255.255.255. Now, our system, we should be understand what is the network ID. If I want to communicate to another system, so it will check both are in the same network or not. If both are in the same network, they will communicate each other. If they are not in the same network, so they cannot communicate each other in a simple single LAN segment. Of course, if you have a default gateway, that is a different matter. But here it is in a simple LAN. You do not have any gateway, so has to be depends upon the same network. It will communicate, otherwise not communicate. So how system will understand? It converts our IP address and subnet mask into binary and do the end operations. First of all, so if you convert the things into binary, this is like a 192 binary, 168 binary. 168 binary is 128, 40, 32. This is 168, 23. So 23 is not in this range. Yeah, this is 16. And this is 23, I think. 7 plus 16. 24. I think I have written this part is wrong. This is correct. 16 plus 8. Plus 8 is 24. Okay. This is a binary transaction of first IP address. Subnet mask is 255. The binary number for 255 is 8 ones. Okay. So I'm writing 8 ones. Okay. So this is our subnet mask. So how it will calculate end operation? What is end operation, guys? Both inputs are 1, output is 1. Any input is 0, output is 0. Okay. 1 0 or 0 1, 0 0 is 0 only. So based on that, we have to calculate. So first of all, we take this number. We'll take this 1 and with this 1. And what is the 1 1? Output is 1. Again, second one is also 1 1. Output is 1. Again, second one, again, third one is 0. Here it is 1, 0 1, 0. Again, next one is also 0 1 0. So you have to calculate from here to here. So here it is. Check this. 1 1 1 1 1 1 0 1 0. You will get it. Okay. So you have to check this and this. You'll get this one. I have to put it like this. 0 0 0 0. Again 1 0 1 0 0 1 0 0 0 0 0 1 0 1 1 1. Okay. So how I calculate? So I have seen things like this. Always from here to here I have written, but any which ways you can do it. From here to this side or this side, you can do it. Okay. So you can see this and this, both are zeros, zeros. 1 0 0 0 1. Here is 0 1, this is 0 1 0 only. But you see 1 1 1. If you see 1 1, it is 1. If you see 1 1 1, 1 1 1, again 1 1 1, like this. Okay. So this is AND operation. If you again convert this back to the um, decimal number, so again it is your network ID. So your network ID, this is the network ID. This is your network ID. Okay. So how to get it original number? So what is this? You transmit again, convert into decimal format, then you will get it. So 192, 168, okay, 23.0. This is your network ID. And now you understand. So how to calculate, convert into decimal binary format, do the AND operation, and again, what is the result is network ID convert into decimal format. Okay. Now at least somewhat understand or totally confused.
Understood, sir.
Very good. Okay. Subnetting is divided into one network into multiple networks. So point of this subnetting. Okay. So for example, you take a class C IP address. Total number of hosts is 254. Okay. So here it is. I already told you have a 50 devices in your network. And what is the best choose? Class C, because it's 254. Why not class B and class A? Because class B more than 65,000 IP addresses you are getting. Class C 16 million IP addresses you are getting. So you are wasting so many IP addresses. This is waste of IP addresses for a just 50 computers, right? This is suitable for a 50, but still you have a 254 IP addresses and you are utilizing only 50. So almost all more than 200 IP addresses you are not utilizing. Guys, in a private IP addresses are free, no need to pay, but public IP addresses are paid versions. Okay, and number of IP addresses are limited. Number of total IP addresses are limited. That too, public IP addresses are limited. Second one is you take a network, you take a one network you have taken. For example, I need a network like this. I have taken a network. This is my network ID. So number of hosts I am getting here is 65,000. But I have only 300 computers, 500 computers, or maybe 30 computers. So what about a wastage of IP addresses? It is not utilized by any other organization, and also you are paying for not using. It means you have 50 computers, but you are paid for 254. Means you are paying for additionally another 200 IP addresses. Okay, you need 50, but you are getting 254. So you are paying for extra price which is you are not utilizing, and these IP addresses are not utilized by any other organization. So it is someone is cannot able to use and you are not using it and you are paying for it, waste of money. Understand concept?
Yes, sir.
Okay, so you are not utilizing 100%, not even 100%, 90% also utilizing sometimes. So we introduce, so this is a subnetting concept is introduced to reduce number of hosts per subnet. Okay. So what is subnetting? Divide one network into multiple subnet. You take a one network. So you take um, um, for example, this class C network you have taken. So for example, IP address is 200.10.20.0. This is a network. So you will get in this network, you will get a 254 host. I'll divide this network into two parts and four parts, or maybe eight parts, or maybe 16 parts. I can divide a network into multiple subnets. Multiple subnets. So each subnet will get a lesser number of hosts. For example, you divide into two parts, you'll get only 128 per subnet. Only 128 hosts per subnet. If you divide into four parts, you get only 64 hosts per subnet. If you divide into eight networks, you'll get only 32 hosts per subnet. I have 50 computers. This is the better solution. This is the better solution. 64. I have 50 computers, one network, 64 computers. So I will get a wastage is only around 10. 10 or 12, maximum 10, 12, 14, like that it is wastage. Maybe I will add one or two computers, no problem within that one, right? Instead of wasting 200, I am wasting only 10 IP addresses. Okay, so this is what I'm trying to say. So you can divide a network into number of subnets. But if you divide a number into multiple subnets, per subnet, hosts will be reduces. Okay, so number of hosts per subnet will be reduces. This concept called a subnetting. So what to do with the subnetting? So how to do subnetting? How to do subnetting? By changing subnet mask. Changing subnet mask. How to do subnetting? By changing the subnet mask. You change the subnet mask, your network, your IP address, things will be changes. For example, you say, I take one example, right? 183.15.33.44. This is IP address I have taken. This is class C, right? This is my subnet. Okay. So what network ID I got it? 183.15.0.0. This is my network ID. Okay. And for example, I taken another IP address is 15.33.44. I change subnet mask. I changed my subnet mask. I wanted to change subnet mask like this. So somewhere I have written this binary. Okay. If you do the ending operation, so you will get almost like up to here. Sorry, this will be changes. Okay, this is the binary transaction of this one and subnet mask in binary, and this is what you will get it in the calculation. So you calculate 1 1 0 1 1 1 0 1. This is 0. This is 1. This is 0. 1 1. Output is 1. 1 1. Output is 1. 0 1 0 1. Output is 0. 1 1. Output is 1. So here it's also all are zeros, all are ones, you get all are zeros. All are ones, you get all are ones. 0 0 1 0. So it is 0 0 0 1 0 0 1 0 1 1 again 1 0 1 0. So it's the same thing. So 0 1 0 1 0 1 and 1 1 again 1 0 0 again 0 0 0 0 1 0 like this. Okay. So your network ID is different from earlier. Okay. What is the network ID here? This is the network ID. Now the network ID is changed. This is our network ID. This is our network ID. Now this is our network ID. Okay. The network ID is different here. Again, guys, simple changes I am making. This is 22. This is 6. Okay. So binary transactions not different from another one. Just first two are same. Convert this one into binary. Okay. 22 0 0 0 1 16 4 2 4 2 0 1 1 0. This is 22. Next is 6 0 1 1. This is 6. Okay. And this is so what is the network ID here? So you will get a same thing. See here it is. Oh, I'm taking lot of time on this one, guys. Just I will finish up and we'll start a new one. So look at this. This is our network ID. So same calculation. This is same part of calculation, same repeated. But if you look at this, okay, 1 0 0 1 0 0 1 0 0 remaining are zeros only. This is also same thing like 4 are zeros, 4 are zeros. This is 1 0 0 1 0 0. So this is our network ID. See, IP address changed. IP address is from here to here changed. Which part? Only host part is changed. This part only changed. And subnet mask is same. So network ID is also same. But if you look at this one, I change the network ID. So the automatically what we can say the network ID also change. I change the subnet mask automatically. Network ID is also changed. So I will show you this part again. Now again, I am with a different network ID. Okay, again like this. So same calculation. Look at observe carefully. These are all same. Only is this is changes. This part changes. Okay. If you look at here, this will be different. So 0 1 0 0 1 0 0 1 0 1 1 1 and 0 1 again 0 1 1 1 1 1 1 0 1 0. You know this is this value is first value is simply can say like a 183 15 22 done 0. See this side I put a network this side I have taken IP address subnet mask default one I got a network ID like this. And I have another IP address in the same network and same subnet mask. I have same network ID. So in this case, these two systems can communicate each other because their network ID is same. So this system and this system can communicate each other. But here I change the subnet mask. I change manually. I change the subnet mask. Okay. So here it is IP address. Here it is an IP address. But their sub network ID is different. Means this system and this system cannot communicate each other. Okay. That system and this system cannot communicate each other. Okay. Just for our understanding, so we have written like this. Okay. So the same example, why I have written same example from here to here to continue. So how to calculate network ID, and this for this one also I calculate network ID. Okay. This network and this network is same, means this PC and this PC can communicate each other. But in this case, if you see, I change my subnet mask. I have changed my change the subnet mask. I've changed the subnet mask in this case. Okay, from 255.255.0.0 to 255, 255, 250, 100. I changed it. We can see these systems cannot communicate each other because of their network ID is different. See, the network ID is different from this to this. Just I change the subnet mask. Guys, understand? So I divide a network into dividing a network into multiple subnets. So when you divide a network into multiple subnets, automatically the host person will be different. Okay. And if you change the network ID, so if you change the subnet mask, network ID also will be changed. I said I will finish off this part, then we'll take it. Okay. So here I will write a note here. 183.15.33.44 and 183.15.22.6 systems cannot communicate due to different network IDs. Different network IDs. They cannot communicate each other due to different network ID. So why their network ID is different? Because even though both are in the same classes, the subnet mask is different. Okay. And this one, in this one, again, I will write this same statement, but little different. Can communicate each other. Can communicate with each other due to same network ID. Okay, same network ID. The same network. Now I have changed the subnet mask. Then you can see the calculation. Guys, so okay up to here. Understand network ID. and subnet mask, how subnet mask affects the network ID. Okay.
So, subnet mask just like it simplifies the network ID, sir. So it
Yes.
works.
Right. Right. Okay. So subnet mask, you can say like this simple. It is from your IP address. It is identifies the network ID. It divide your network portion and host portion. It simply very good. That is good understand. Okay. It divides network ID. So it divides IP address into network portion and host portions. Okay. So it will take from your network using subnet mask system can understand what is the network ID. So same network ID communicate each other. Different network ID cannot communicate each other. Okay. Subnetting, this is different subnetting concept. It is, we should not enter, but both the same subnet concept for understanding subnetting concept. So this is basic level. Okay. But I'm not giving anything related to subnetting calculation. I'm giving only subnet mask, sorry, using subnet mask, how to calculate network IDs. Okay. I given that one. Okay. But I didn't given how to calculate this subnetting concept. Okay. Subnetting part I'm not doing. Okay. Just I'm going to tell what is the slash notation, that part. What is a slash notation? This one, guys. If you have an IP address, you have an IP address. So how to write an IP address? IP address and subnet mask. Okay. Okay. How to write an IP address? Okay. For example, you are telling your IP address. I'm telling my IP address. Okay. So how to tell an IP address? So IP address, telling IP address with always with IP address. Sorry, always with a subnet mask. So you can tell IP address two ways, three ways, four ways. Different things are there. So understand that one. You can tell your IP address or any IP address in different ways with subnet mask. Okay. So example, you can tell my IP address. For example, my IP address is 192.168.2.23. That is IP address, and my subnet mask is 255.255.255.0. Okay. Example, my IP address is any IP address. IP address is not area. Is 192.168.2.223, and subnet mask is subnet mask is 255.255.250. Okay, so like this you can tell, or you can say, yeah, my IP address is 192 dot sorry, 172.16.0.112. That's it. If you don't tell subnet mask, it will take default. Either you can tell subnet mask, or if it is a default subnet mask, no need to tell subnet mask also. Okay. Okay. So you can say like a, yeah, that's it. Okay. So it means actually subnet mask is subnet mask is default one. What is the default subnet mask of this particular IP? What is the default subnet mask? It's a class B. What is the default subnet mask? Okay, that is the default subnet. Guys, you can tell with a subnet mask without telling subnet mask. If you subnet mask is not mentioned, it is default subnet mask. Subnet mask is mentioned, so you have to look at the subnet mask carefully. That is the thing. If you use different subnet mask than default, means customized subnet mask. Okay, it means uses customized subnet mask. If you use different subnet mask than default one, so it means you use a customized subnet mask. Okay, so you must mention the subnet mask. Subnet mask. So example, again, my IP address is we'll do 172, 16, 23, 34, yeah, 33. So it's a good one. Okay. And subnet mask is 255.255.2, so 240.0. So different subnet mask. I'm using different subnet mask here. Or same, you can mention like this. So 172, 16, 23, 33 slash 240 is 8 plus 8 plus 16 for 20. Okay, like this. Okay, so example is you have an IP address and the subnet mask is like this. Okay, so you can mention a specific subnet mask if you do not mention the subnet mask. If you don't send the subnet mask, so you can think it is a default. I said take 192.168.1.2. I didn't tell subnet mask means default subnet mask. If I specify the subnet mask, compulsory check the subnet mask is a default one or a changed one, means customized one. It's a subnetted subnet mask. Okay, so you can see here it is. This is my IP address and I have some subnet mask, different subnet mask it is. Okay, you can mention like this or you can mention like this. Both are same. Both are same. Just you say 250 to 40. The 4. Okay. 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 What is this? What is this part? What is this part? Okay. This is called a slash notation. Normally, you know this how to represent, but this is called a slash notation. So represent subnet mask. Okay, the slash notation represents subnet mask. It is number of ones in the subnet mask. Number of ones in the subnet mask. So some people pieces called a slash notation or prefix or CIDR method, classless inter-domain routing method. What is this method is nothing but representing a subnet mask into the slash notation. Okay, prefix, slash notation, CIDR method. Simply say it is a slash notation, representation of subnet mask in a simple slash. So what is this 20? It is represent number of ones in the subnet mask. I will show you the calculation below. So you can see this. This is 255.0.0.0. If you write in the binary, how many ones are there? See, 8 ones only there. This is /8. Okay. So if you see, this is 255.255. 0.0. It's a class B, right? /16. Why /16? 16 ones in the, if you write this one into binary, you have a 16 ones. This is /24 means 24 ones are there. If you write in the binary, you see there is a 24 ones in this subnet mask. That's it is /24. Okay. This is /20. I have written /20 here because it's a 240. So how it is? First 255 is about 111, 111. This is 255. And again, second 255. Next one is 240 convert into binary. This is, and remaining is 0. So this is like this. Okay. So if you count these all ones, it is 20. So it is /20. That's why I written /20. Instead of writing this subnet mask, I can write like this. Okay. So you can see this is 192. So first to 255. This is first 255. Second 255. 192. Convert into binary. Okay. Now it is, if you count all these ones up to from here to here is /26. Okay. So these are some other examples. So what is this? It is 172.16.1.23/16 means this is an IP address and this is a subnet mask. You write an IP address and /22, it means this is an IP address, this is a subnet mask. So what is 22? So how to do this one? How to do this one? How to get it? How we will get this one? Put a 22 /22. So here it is /22 means 22 ones. First 8 ones completed. Next 8 ones completed. So 16 ones are completed. 22 by 16. 22 minus 16. 4 plus 2. 6 ones. 6 ones completed. Remaining 0. 22, right? So 1, 2, 3. Fourth octet. 0. See, right? This is first one is 255, 255. 8 ones are completed. The next one is this. This is, you should convert into binary. These are all ones, no problem. But this is, you should convert into binary. Yeah, it is 240, 240 by where is the calculator? Better to show in the calculator. I can calculate, so that's for me no problem. 11111100. This is 252. This 252. Already written, but how to do it manually? How to calculate? I can show the from there. Okay. So this is my IP address and this is my subnet mask. You write a /22, put a /22 in all one in numbers and write down your subnet mask and you will understand exactly what subnet mask it is. Okay. So guys, this is a CIDR method or slash notation or a prefix method. So it is represent your subnet mask. Instead of writing like this, you can write like this also, or you can tell like this. So what is your subnet mask? What is your IP address? You said like I have an IP address 190.16 168.2.44 /26. Okay, or 27. So it represent automatic /27 represent the subnet mask. Okay, so that's the point I try to say. Okay, up to here. what is a slash notation? So when you see an IP address with a sub IP address and subnet mask, or IP address with a slash notation. If you any IP address without subnet mask means default subnet mask only. Okay. If someone is not representing like this, a subnet mask, okay. If they mention, good. Not mention, default subnet mask. And also we can mention like this. Yeah. Any questions up to here, guys? Hmm? Anybody need a break?
So what is slash after number means, sir?
What is this slash after number?
Yes, sir.
This number means number of ones in the subnet mask. The maximum is 32. Okay, maximum is